Hello everybody, today we're going to be talking more about solutions of quadratics and how to find them. Specifically, we're going to talk about how to find them using the zero product property. So in this property, in order to use this property, something very important that we need is we need the polynomial. In our case, it could be a quadratic in what's called factored form. So we've talked about factoring quadratics in a previous chapter. So we'll remind ourselves of that, okay? But let's quickly review the difference between what we would call a standard form of a quadratic versus what we are now going to call factored form. We've called it that before, just want to be a little more specific. So standard form of a quadratic would be something written in the form of ax squared plus bx plus c, so something like x squared plus 2x. Factored form is a product of polynomials that you get when you factor this. So this, for example, has a GCF of x, and you get x plus 2 when you divide that out. This is the standard form. This is the factored form. Another example could be something like x squared plus 5x minus 24. That is your standard form of a quadratic. The factored form of that would be two binomials multiplied together. So the product of x plus 8 and x minus 3. So that is the difference between standard form and factored form. Okay, so when one side of an equation is in a factored polynomial and the other side is 0, we're going to use the zero product property to solve. Okay, so it's going to allow us to solve the equation, meaning find the values of x that make the equation true. Okay, remember that there are many names for the solutions. The solutions of a polynomial can be called the roots. Okay, so that was one name. We've also made the connection that sometimes they're just called solutions. Other times they're called the zeros of the functions. And then graphically, they're called the x-intercepts. Okay, but oftentimes when they're talking about the solution of a polynomial where it's set equal to 0, they like to use the word roots to represent the name of those solutions. Okay, so let's talk about what this zero product property states. Okay, so down here we'll talk about that. And it's the idea that if the product of two or more real numbers, so just values, numbers, if you know that their product is 0, then we know that at least one of the numbers is 0. So let's take into account the idea that you have, let's say you have a value of a times the value of b, and you want it to equal 0. Now, if you made one of those be 0, let's say that you had a was 0. So if a equals 0, what would happen is you would have 0 times b equal to 0. Similar to that, let's say b equaled 0. So if b equals 0, it would be a times 0, and you would get 0. So as long as one of these numbers equals 0, we can say that the whole product will equal 0. So we will say that if a times b equals 0, then we know that either a has to equal 0 or b has to equal 0. At least one. Now they could both equal 0, but at least one of them has to equal 0 in order for the whole product to equal 0. Okay? And again, we will use this property to help us solve polynomials in the quadratic form. So let's look at an example. In example 1, it's going to say solve, okay? And we are going to solve using the zero product property. The zero product property, when you see zero product property, I want you to immediately think factoring. Right? So let's look at number 1. So in number 1, we have 2x squared equals 8x. Okay? Now remember, in order to use this zero product property, you must have, let's go back to the top here. It says when one side of an equation is a factored polynomial and the other side is 0. Okay? So that right there tells you that I need to have my equation set equal to 0. So to use the zero product property, the first thing that you're going to want to do is you're going to want to set your equation equal to 0. So that means you're going to have to move things around using inverse operation. So I can very easily get my 8x to the other side by subtracting 8x on both sides. And remember, the reason why this cancels out is it cancels out because it equals 0. So it cancels out, but yes, it equals 0. So on the other side, you're going to want to write your terms in decreasing order by the exponent. So make sure it is in standard form. So setting it equal to 0 so that it's in the form of ax squared plus bx plus c equals 0. Okay? So after you have set it equal to 0, your next step is going to be to factor the polynomial. We have all different types of factoring that we learned. Remember that the first thing with factoring that you want to look for is a GCF. Okay, so I'm going to first check for a GCF. I can see that between these two terms, I do have a GCF of 2 and I have a GCF of x. So I'm going to divide out a GCF of 2x. And again, if you can't do that in your head, then maybe you need to think, okay, I'm going to divide by 2x, leaving me with x minus 4 inside the parenthesis. Here's where we're going to actually use that property. What you're going to do is you're going to set each factor equal to 0. Because what we have here is it's sort of like this is my A and this is my B, right? So if my A equals 0, meaning 2x, so one thing that can happen is 2x could equal 0, because if 2x equals 0, that would be 0 times x minus 4, which would give me 0. Or my other option is my other factor of x minus 4 could equal 0. So this is the idea of setting each factor equal to 0. Once you've done that, you're going to now solve for x. So solving this one for x, I get x equals 0. I can do that in my head. Solving the other one for x, I get x equals 4. So the solutions to this problem, or this quadratic, is going to be x equals 0 or 4. And we can just list them out like that with a comma, and there you have it. That's your answer. To quickly just make the connection to this, if I were to graph this, and there's the graph of 2x squared minus 8x, look at where our graph crosses the x-axis. It crosses it where x is 0 and where x is 4. And those are the exact same two x values that we got. So just trying to make the connection between what we have learned before and what we're doing today. So we're just solving these without doing any graphing at all. So let's look at a second example. In a second example, I have x squared minus 3x equals 10. This is not in standard form, but we can definitely get it into standard form. So, and I can do that by subtracting 10 on both sides, leaving me with x squared minus 3x minus 10 equals 0. So now what you're going to have to do is you're going to have to factor this quadratic. So you want to take a moment and factor that. Remember, this is when a equals 1. So really you can just think about what is two numbers that have a product of 10 and a sum of negative 3. Sorry, a product of negative 10 and a sum of negative 3. And that would be a negative 5 and a positive 2. So here you have your two factors. Here's your A. Here's your B. In order for this whole thing to equal 0, you either have to have this factor be equal to 0 or this factor be equal to 0. So my two options are x minus 5 could equal 0, or x plus 2 could equal 0. Leaving me with the answers of x being, from this one, I would get x equals 5. And from this one, I would get x equals negative 2. So there are your answers. Okay? All right. So I'm going to put a few more examples here for you to look at. Let's look at something like, let's do 4x squared. I'm going to put two more examples here for you to try. So for number okay, so let's look at two more examples here for you to try, not only putting them into the standard form set equal to 0, but also the factoring portion of the problem. So let's look at 4x squared plus 9 equals 12x. And then we'll also look at the example of 2x squared minus 32 equal to 0. So that one already set equal to 0 for you. So press pause, give these each a try, and we'll come back and review the work and the answers. Look at 3 and 4 here. I have the work and the answers. So if you got the right answers, you can go ahead and move on. But if you had any questions, just quickly take a listen to the explanation. So on number 3, I had to subtract 12x on both sides to get it in standard form set equal to 0. I solved the left-hand side, which happens to be a perfect square trinomial. Those will always factor into two identical binomials, making it easy to factor. Remember, a perfect square trinomial will have a first and last term being perfect squares. So I went ahead and factored it pretty easily because of that. Remember that you have your two factors. Here's one of the factors, and here's the other factor, and you can see here I've set both of those equal to 0. When I solve this, I get x equals 3/2. And you can just leave it in reduced fraction form. You do not need to change it to a decimal or a mixed number. If I were to solve this one, I would get exactly the same answer. And I'm not going to write x equals 3/2 and x equals 3/2 because it can only equal 3/2 once. So this would be an example graphically where your graph only touches the x-axis at one place, having one x-intercept. On number 4, it was already set equal to 0. Noticed it had a GCF of 2, took that out, and then finished factoring what was left. And this happened to be a difference of 2 squares. Remember, difference of 2 squares. 2 perfect squares with a minus sign in between will always factor into 2 binomials with opposite signs in between the terms. You don't want to forget your GCF out here. Sometimes it's always really important. And I'll talk about what this means in a moment. I set this equal to 0, and I set this equal to 0. You can see that work down here, giving me x equals -4 and x equals 4. Now, this GCF on the outside, yes, it is a factor. So in my head, I'm sort of thinking about if I set that factor of 2 equal to 0, that would basically give me something that's untrue. 2 does not equal 0, right? And the idea of setting these factors equal to 0 is to solve for x. If a factor does not have a variable involved in it, then we don't need to set it equal to 0 because it doesn't give us a solution for x. So even though 2 is part of the factored form, it is not part of helping me come up to the final solutions. So the final solution for this is x equals -4 and 4. Some of you might be familiar with this symbol, plus or minus. Plus or minus is just a shorthand way of writing these answers of -4 and 4. You can write the answer either way. You'll see more with this plus or minus in lessons that are coming up here very soon. So I hope that this video was helpful and a good review of factoring as well. So hit like on this video and good luck with your practice.